Hello, welcome once again. Found a pictorial that I think will make things much more simpler rather than concentrating on schematics for beginners. This is the actual, like the components, like we know them, and this is the guide of how they work. So let's start from the beginning. Obviously, this is the battery. Now, the negative of the battery goes to the body or the frame, to the engine body or engine frame, anywhere that's metal, that's conductive. So we know that. So this is minus over here. This is minus, the black lead. The red lead, which is the positive, which is the red one. In this pictorial, let's say, goes through a junction box, which is just a connector. Think of it as a switch. Goes to a solenoid, which is with the starting motor, the starter motor. The other side of this junction box goes through an ammeter, which we don't need, which measures current, but think of it as a straight wire. Goes through the ignition switch, which you turn to start the car. So as this is activated, the solenoid, which is a relay, this is given 12 volts through this switch to turn on the starter motor, and the starter motor is grounded by the housing. So that's step number one. That's what happens when you first turn on the car. Now, I'll take it a step further. There's headlamps, there's horns in this, there's an alternator, there's spark plugs, and there's a distributor. So while this is going on, this is connected to obviously the flywheel, which is actually connected to the crankshaft of the engine. We need to get fuel and air into the engine. So over here you have a distributor, like we said. We have an ignition coil, which will create the spark, and this will, in part, give the spark to the proper cylinders. So let's say if you have 8 spark plugs, you are dealing with a V8. 8 cylinders, 8 sparks. So spark is here. Okay, now, as the engine turns, we have an alternator. The chassis is ground. The housing is ground, as you can see. Once the engine turns, obviously, we have 13 to 14 volts approximately going back to the battery. Now look at the connection. Yesterday we spoke about a video, common bus line. This B plus line, the 12 volts here, 12 volts, 12 volts, is a common bus line. Everything is connected to it. So therefore, once this battery is discharged by giving 200, 300, 400 amps, whatever it's supposed to give, which is this line over here to the starter motor, he takes over. He takes over. When he takes over, he's not only feeding, now look at the lines connected, not only feeding the battery, recharging it, he's also feeding this through the starter, the ignition switch, the distributor for spark, and also for fuel, the fuel injectors. Now, let's say, in addition to that, after obviously the engine has been cranking, this is no longer leaded. So he's keeping this alive, he's keeping the spark alive, he's keeping the fuel going to the fuel injectors alive, plus other sensors. So this 13 to 14 volts also on this common bus line is also going to the headlamps and the parking lights and the tail lights and the light switch. Also, see another one going to what? A horn relay. This is the horn button. When you press your on the steering wheel, you depress it. This is what you're doing. You're activating the horn relay to these two horns. Now, hopefully you understand this a little better than schematics. Let's troubleshoot if we can. In the morning, you try to start your car. You put on the light switch. The lights do not go on. From this pictorial, can you diagnose what you think the problem is? I think this is easier than a schematic. And remember, You put the light switch on. You're expecting to have the headlamps on or the parking lights on. You don't. This is not activated, obviously. Starter mode is not being activated. Can the problem be the alternator? Your first response should be, no way. How can the alternator be the problem? The engine is not even spinning. The starter motor is not even spinning. If the starter motor is not spinning, forget about the engine spinning. Can the problem be a distributor? No, because if the distributor is the problem, we can still have the starter motor turning or trying to turn the crankshaft and the camshafts. Can the problem be a junction block? Now think about this. If the junction block is bad, right, it'll take out what? The starter motor. But the lights, there's still a path for the lights to come on. Your problem is your lights don't even come on. Okay? Can there probably be an ignition switch? If the ignition switch is bad, look at this. If the ignition switch is bad, will that stop you from having the lights on? No. Even if the ignition switch is bad, you should still have the lights on. So right away, the fact that you don't have the lights on, either the headlamps or the parking or whatever, high beam, whatever, what does that tell you? That tells you to look for something from the battery that knocked everything out at one shot. What do you think that is? If you come over here, a ground or the positive leads. This, by not having a return path, will knock out everything. That means I can't even have the lights on. If this positive cable is broken or has corrosion on it, which it usually does, that means I don't have 12 volts. I have maybe 10 volts or whatever I have. That's not enough to start even the lights. If I can't even start the lights, that tells me I cannot even start the starter motor or obviously the distributor and other things. So the fact that the lights in this example didn't come on when I tried to put it on in the morning and a no start told me it's something common from the battery. What's left from the battery? This one, the black one, right? Could be corrosion on the negative. Could be this is not making a good contact to the body. Sometimes it might be loose over here in the terminal, might be loose over here on the engine block, might have corrosion over here like we always know, might have corrosion over here like we always know. This one could be broken also. Or you might have an excessive voltage drop across this. If you have an excessive voltage drop across this, guess what? Less voltage will be coming here to light the lights on. Now, you're asking yourself, if I have excessive voltage drop across here, that means I lose the starter motor. Let's say instead of 12 volts, I lose 0.5 volts or more, 0.7 volts. That's enough to knock out this starter motor. And also this one. So that's how you diagnose. I just wanted to bring about something a little different. Now let's say your headlamps go on, but your parking lamps do not go on. What could be the problem? Can this be the problem? Can the battery be bad? Can the ground be bad? Not really, because if you look at this, if this would be bad or this would be bad, I wouldn't be getting any lights on. So the fact that I even have the headlights going on, that tells me what? This junction block is good. And forget about the ammeter, but this is good. This wire is good. This light switch is good. But what's the problem? These are not coming on. This wire over here might not be good. Or these grounds, if they both have the same ground, might be the problem. So this is how you diagnose, but this is just obviously a little pictorial, an idea to give you a clearer idea how your car starts. So please go to my channel, Joe Electronic Schematics for Auto, and my other one, Automotive Electronic Schematics by Joseph, where you'll see, like I said, use relays in the circuit, in the fuse panel. I don't take them out, and you can see those. And like I said, Within a couple of weeks, we'll do much more hands-on instead of the theory, and you'll see everything much more clearer. Thanks for watching.